We are live. I'm going to give a few minutes for folks to come in. Just a couple. So while we wait for folks to come in, we can talk about yesterday's prime number fiasco. So I went and looked at the code a little bit, and it occurred to me we were trying to build an array with something like 10 billion entries, which is never going to work. We're trying to build a range and then convert that to an array with something like 10 billion entries, so it's never going to work. So I'll come back to that one at some point, but we're going to have to figure out an algorithm for it that makes that much smaller. So the reason it's difficult in Dataweave is we don't have a simple for loop in Dataweave because we have maps and reduces and things like that, but we have to have something to map and reduce over. We can't just say for x in whatever, for I in some number, and then just sit there and loop. And so we have to figure out some way. We could do it in Mule, because we could do like an until successful um, and just sit there and loop and loop and loop and loop and loop, right? Um, or we could do well, there's a lot of ways we could do it in Mule. We could like programmatically create like smaller chunks of data and do like parallel for eaches over those. Um, and we could do like a for each where we figure out like how many chunks do we need. We could create like an array of like 10,000 and chunk that out or whatever. Even then, it's still going to take a long time and it's going to be huge. But yeah, there's a lot of ways you could do it in Mule, but doing it purely in Dataweave is actually kind of difficult, right? This is why Dataweave is um, it's a transformation language. So we're doing things that it's not particularly optimized for. All right. So I think we got a couple more minutes before the top of the hour. I just wanted to get on early, and if you guys haven't figured out, I enjoy doing this. So um, hopefully we'll have one or two folks hop on here in a minute. So if we look at today's problem, we're going to be looking at something I think is much more manageable, similar to our what was the name of the problem I worked on yesterday afternoon? The palindrome. Similar to that one, where it's much more manageable conceptually, I think. This is the smallest number that can be divided by each of the numbers from 1 to 10 without any remainder. So we're going to brute force this one probably. But I bet we could brute force it in a way where it's pretty quick. So what is the smallest positive number that is evenly divisible by all of the numbers from 1 to 20? Yeah. So we'll solve it for like what is the smallest number that can be divided by each of the numbers from, so we can solve it easily with something like, so 1, 2, 3, 4 would all be like 12 would be evenly divisible by 1, 2, 3, and 4, right? So what is the smallest number that can be divided by each of the numbers from 1 to 4? 1, 2, 3, 4. Yeah, that would be 12. So we could write a test. We'll write a test to deal with that, right? And then and solve that, and then we'll solve it for 1 to 10 with 25, 20, And then we'll figure out what the smallest number that's evenly divisible by all of the numbers from 1 to 20 are. So, okay, well, we're at the top of the hour, so let's get started. So once again, for those who might be new, we are using the Dataweave library and the Dataweave testing framework that is available as an extension in Visual Studio Code. Um, I haven't done any kind of changes beyond the simple tutorial for using the extension. Um, and it works pretty well for me on Mac. So, although I will say this, I installed the newest version, the new OS for Mac, the, let's see, what is it called? Sonoma this morning. So we're going to find out together live if that created any issues. Yeah. So let's do that. So we have smallest multiple. So we're going to do new module. We're going to call this smallest multiple DWL, and we're going to call this def find smallest multiple, and we're going to take an argument of let's call this smallest multiple. We're going to take the start. We'll just do this. Start is going to be a number, and end is going to be a number. Right? And we're going to return a... Oh, this isn't def. I keep trying to write this as if I'm writing Ruby. I don't know why. I haven't written Ruby in years, but whenever I define a function, I want to define it like I'd be doing it in Ruby. Yeah, so find smallest multiple. We'll take a starting number and an ending number, and we're going to return a number. And in this case, we're just going to return 0 as our placeholder because we want to have a failing test. And we're going to scaffold out our test. So for those of you who are new, it's just a simple, in this Visual Studio Code, it's as simple as clicking Add Unit Test, and it creates a new file for that particular module, sets up your libraries, imports the module that you're working on, and sets up your test based on that. So find smallest multiple, it should return 12 as the smallest multiple for a start of 1 and an end of 4, right? So if we say start, look, it even knows my arguments here. So we're going to do 1 and 4, and it must equal to 12, right? Cool. So if we run this test, it should fail, but not blow up. I figured out how to do the shortcut for running the test, so we'll start using that. It's on my Mac, it's Command semicolon and then F for file, so that'll run all the tests in the file. Let's see, we got our debug console. Let's do test results. Okay, return 12, but it was 0. Perfect. So now if we run 12 and save that. So for those of you who are wondering why I'm following this pattern, I'm doing this TDD style. So you write, I'm not doing pure TDD because I'm not writing the tests before I write any code. I'm scaffolding it out and letting the tools build the initial test for me. But write a failing test, make that test pass. Write a failing test, make that test pass. And that's going to drive my code to be more modular. There are strengths and weaknesses of doing this way, and I haven't really talked about those yet, but I think this is going to be an easy enough problem today. We can probably have some of that conversation if folks want. So, okay, so let's see. Find the smallest. So, command, colon, file, run our tests. So, one of the advantages of it is if you're doing greenfield code, never touched any code, never solved this particular problem before, which is the case with all of these, right? It's good because it makes you think about the way you're writing your code in such a way that it's easy to test, and it forces you to, um, well, it encourages you, it doesn't force you, but encourages you to write code that's easy to refactor and easy to, it's composable, so you can move things around. So we saw that some yesterday with our palindrome product code, where I wrote it, and then as soon as I started it becoming very obvious that, this can be extracted out into its own function, this can be extracted out into its own function, and the test drove that process. So it wasn't, you know, anyway, we'll probably do some of that today as well. Okay, so we have a passing test, and we've just hard coded this to 12 for right now. So let's write another test that won't pass. So what is the returns? What is the smallest multiple of 1, 2, and 3 is going to be 6. So let's do 6. It returns 6 as the smallest multiple for a start of 1 and an end of 3, right? In do. So find smallest multiple, 1 and 3 must equal to 6. So this will fail. And now we actually have to do our logic, right? We can't just hard code our answer. So what's the best way to do this? So I think we're going to, yep, good. So we're going to create a range, convert that to an array of all of the numbers from our start to our end, right? Because we need all of those to work as, and we're going to just use modulo and say, oh, that won't work, so equal to 12, but we need to know the actual multiplier, right? So, I get it. Yeah, so we just need to do 1, 2. Is there a brute way to do that? So is it always going to be an even number? It's always going to be an even number, right? Yeah, it's always going to be an even number. So we can create an array of even numbers and test them. It's always going to be, this is going to be a brute force thing. Yeah. So what's the best way to create an array of even numbers in Dataweave? Yeah, so what we need to do is just create an array of even numbers, test that they're divisible by all of the numbers that we care about, and return true. This might actually be a large number. So if I create an array of 1 to 10,000, is that going to work? Yeah, let's try it. So we're going to create an array. First thing we're going to do is create an array of 1 to 10,000 as array, right? And then we'll just filter out So what's going to be quicker? Throwing away all of the odd numbers? We'll try it. We can optimize later, right? We'll just filter is even $, right? And for now, let's just grab the last one and see how long that takes us, right? This is going to fail. File. But we want to see how long it takes to do that. And if it can, if Dataweave can even create an array that large. I think it can. 10,000 is a lot, but it's not astronomical. Expecting root to be 6, but was 4. That's interesting. Why would this... Oh, because it's the first item, right? So I said -1. Let's do -1 and see if it returns. Yeah, the first item would have been 4. Yeah, so it can handle that. Yeah. Should get back 10,000. Come on, Dataweave, you can do this. Yeah, perfect. All right, so we're getting even numbers. So let's make this a variable. We're only going to support probably up to 20, but see, var evens up to 10,000 equals this. And then, we're just going to take the -1 off the end. Okay, and then we're going to say evens up to 10,000. So you'll notice that Visual Studio Code is yelling at me right now. It's like, hey, something's wrong here. That's actually because I've said that this function is going to return a number, and right now I'm returning an array. So Visual Studio Code is smart enough to do that kind of syntax checking. As long as I tell it what my types are here and do a function that takes an array and returns an array, it can return its expecting type number but got an array of numbers, right? So it knows what I've got. It's nice enough to do that. So, but if I do like square root 0, the error goes away because now it knows, oh, it's an array of numbers and he's returning an item in that collection. So now we're going to reduce over this and find the smallest number that can be divided by each of the numbers from 1 to 10 without any remainder. So actually, interestingly, this is going to be a constant. This is always going to take the same amount of time, and it's only going to work for up to certain numbers because of the way we're doing it. So it's actually going to be a constant test because we're going to iterate through the collection, do our checks, and since we're doing a reduce, we're going to go all the way to the end. We're not going to do first. Actually, can we do first? That might be quicker. So Dataweave reference. Might not use a reduce here. So we want let's look at the arrays module. We've got first with returns the element that satisfies the condition or returns null. The first element that satisfies the condition. Yeah, I think we can use first with on this. Let's try that. Let's see. Why don't we solve it with first with, solve it with reduce, and see if there's a difference in performance between the two. So we'll see. First, let's just do it with first with. So import first with from DW core arrays. That gives us first with number and then I think we're also going to use all. So we want another variable here that is our candidates. Var candidates equals start to end as array, right? And we will say candidates. All right, we'll do, let's look at our all function. Let's go back. Is it, it's in core, I think. Core, no. Contains, ends with, entries of, is it every? Let's see, every. It's not in core. So let's try arrays. Is it every? Yeah, here we go. Returns true if every element in the array matches the condition. Great. All right, so we want every and first with. We're using a couple of functions I don't use all that often, which is why I couldn't remember what it was called. Let's do every. So give me an example of the use of every. What's the syntax look like? So it's the array and then every and then the thing. So we'll do candidates, every, and then we have mod already. Let's do this. Star, or no, number, mod, $, equals 0. All right. First with. So what's this going to yell at? Expecting type number, but got null. So if we do this, right, and then default it to 0, like I don't like that because it could in theory return 0 as the answer. Is there a way on a Dataweave function to define number or null? Define function output Dataweave. Define Dataweave functions. Sample function. Output. Type constraint. Here we go. Result type equals. So if we do optional parameters, yep. Optional parameter order, function overloading. This is all stuff I know. Can we just do or null? Or null? Does that work? And then if I take this off, does that work? Yeah, there we go. See, the language makes sense. You don't even have to know the syntax. Yeah. So, figured that one out on my own. Let's hope that works. Okay, so Great. Got that working, we think. So what happens if we test it? This is going to take a little time. Oh, it's not too bad. Hey, we have tests that are passing already. Hmm, that's awesome. We didn't even need to do anything crazy. So we have evens up to 1,000. First with number candidates, every number mod. Yeah, so this is a little hard to read, but it works. So I guess the question is, fingers crossed, from 1 to 20, is that going to return, is that a number less than 10,000? And if it's not, can we do it up to 100,000? So let's try. So wow, this is quick. I didn't even need to write any. We'll have to refactor it. So it returns question, question, question as the smallest multiple for a start of 1 and an end of 10. Oh, we can do 10, right? Because we know the answer for 10. 10 is going to be 2520. So let's write that test now. 2520 and do, and this should just take the same amount of time, right? 1, 10 must equal to, actually it might not take the same amount of time because we're doing first with, I'm going to do 2520, save, run the tests in the file. This should work. Yep, it works, and it's um, 437 okay, 37 milliseconds, 5 milliseconds, and 336 milliseconds. So there's definitely a time difference based on the first width. So that makes me think that it is taking advantage of. So it was probably better that we did that instead of using reduce, right? Because with reduce, we would have checked, checked, and then once we had one with an answer in it, we would have just returned the accumulator, right, until the end. So this is check, and once it finds an answer, I guess it's breaking out of the loop. I don't know. Can we find the definition? There's a way in here to, yeah, here we go. Go to definition. That's another cool thing about Visual Studio Code is you can go to the definition of your Dataweave functions and see what they're doing. So first with is going to return, oh look, they're doing the same thing we are, or null equals do filter array condition blah blah blah, helper function to work with a null value. So filter array condition 0. Oh, you know what? It's exactly the same as reduce, right? It's just doing in a filter, doing the array. Oh, yeah. It's just not, I wonder why. So it's not breaking out. It's just running through the full filter, just like we would do with a reduce function, and taking the first result, which we could do it that way. They could do it that way. They're implementing the Dataweave in Dataweave, right? Or we could return. So they could have implemented this two different ways. The way they're doing it is filtering everything, returning the first result, or we could reduce with a null as our accumulator, right? And then as soon as we get a value, we set that to be our accumulator. And then from there on, if we have an accumulator that isn't null, just go to the next step. until you get to the end, and then at the end you'll have your accumulator, which is your result. Or you could, yeah, I mean, you could do what they're doing, which is just build the collection and return the first element. Um, Interesting. So that's cool to know that that's how they implemented that. I wonder why we're getting performance differences between these three tests. 37, 5, and 336, because it should be running the filter over the same size of collection every time, right? Hmm. Oh. Um, cool. So let's figure out our result now. So it returns question, question, question as the smallest multiple for a start of 1 and an end of 20 in do. Find smallest multiple 120 must equal 2, and we'll just say 9999 for now. It's probably wrong, almost certainly wrong. The odds of us being right on that guess are, well, we know it's wrong because the return result's going to be an even number, right? Okay, so let's do that and that. And I think we are, but was null. So it's bigger than 10,000. So what happens if we add a 0 to this? And find out then what our answer is. At some point we're going to hit diminishing returns where Dataweave can't effectively through a collection build an array that large. We're going to run into the big number problem we ran into yesterday with the primes. But it's still running quickly. So let's add another 0. We're getting into big numbers, getting into big numbers. Why did my Apple Music just open? Quit. Don't use Apple Music, it just opened up on me. Okay, one more time. I think Dataweave is doing some kind of lazy optimization because that one test is still really short, which is cool. This is a good sign. Nope. Ladies and gentlemen, we have a problem. We're going to have a very big answer to that question. So, one more 0. One more 0. One more 0. But yeah, Dataweave's doing some kind of lazy optimization for that. It has to be, which is cool. It's good that the language is that optimized. I commend the developers for dealing with people who are doing stupid things like this elegantly. It is taking its time. Oh, we have a problem. So it took, what, 1905 milliseconds to return. 19052. Hmm. Let's just keep adding a 0 on here and then see what we get. Yeah, because this is staying constant at around 5 milliseconds. That's really impressive that it's working. That Dataweave's handling that elegantly, like that. 38, 294. So this one's hovering around 300, and this is staying at constant of 5 milliseconds. I'm really impressed. Well, let's see if it takes over a minute to calculate. If it does, it's breaking the quote unquote spirit of the solution, which, I mean, makes sense. We are brute forcing it, right? Looks like it is going to take over a minute. And I have a dog that wants to play. It's his morning playtime. He has a squeaky toy. Yep, that's right. I squeaked it. All right, now I'm gonna throw it. 1, 2, 3. Go get it. There he goes. Oh, and he's back with a squeak toy. Well, we've definitely hit our minute mark. Um, Come here, buddy. Let's see how. You have doomed yourself to an eternal loop of playtime. Yes, I have. Um, the dog has the oh, and it did not return a result. That is depressing. Um, that is very depressing. Okay. So, I wonder what the actual answer is to this. So, it took me how long? Let's see, let me grab the number. So, it ran for 167 seconds. So, about less than 3 minutes and did not come up with the answer. That is terrible. Um, so I am open to suggestions on refactoring because this is not going to work long term. Um, I guess we could candidates every. I don't think throwing this away would help. Like not using evens, right? I think that it would just make this longer by a factor of 2. But building this and then throwing it away, because it seems like Dataweave is smart enough to like optimize and handle that. So, okay, well, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're gonna hit 1,000,000 here if we do this. And I think that is probably gonna be where I'm gonna run this, but I'm not gonna expect folks to stick around and see it finish. I'll stay on the call and chat with folks if they want to, but I'm just curious to see. I guess we could look up the smallest multiple project Euler result. Could you do it in parallel, chunk it, and let Dataweave work with it? Maybe. I guess we could. We could like chunk by, right? And the only problem I think with that is, yeah, we could do that. So we would do this, chunk it, and then what would we do to make Dataweave process of the chunks in parallel though, right? Is there a way we could get Dataweave to do that? I mean, we could in Mule, right? Because we could just build the chunks and then do like a parallel for each and get Dataweave to handle those, and then for every successful result at the end, it just grabs this. We just grab the smallest number. We could order the successes at the end, right? And then at that point, we could just make the number as large as we need to make it. You know, as long as the CPU could handle it. Um, but to get Dataweave to process those in parallel, I would have to do a chunk by, and then do a map. And I don't know if Dataweave would process that map in parallel, right? It might. We could try it. So we would still want the first width, right, for each of those, but we would want to break this into chunks and then map over that chunks, and then we would do the first width on the map, right? And then throw away the. Could you use anonymous functions for each chunk? Yeah, yeah, of course. Um, yeah, you could definitely use anonymous functions for each chunk. So yeah, so I guess we could try that. While this runs, I'm gonna do that. So we want to let's see Dataweave functions. We want to go to our documentation. So we've got this chunk by in core. It's gonna be like split by, right? Or um, group by. So split by splits a string. Let's go look in the arrays. Functions. Arrays. Breaks up array into subarrays that contain the specified number of elements. There we go. We could do that, right? We'll do that. So we'll do a divide by, and then divide it by like, I don't know, 10,000 or something, right? So yeah, so this is still running. We're not going to be able to, so let's do this. Um, so let's write a function and break our first width out into that function, right? So function evaluate candidates is going to take a candidates and a I'm going to take a candidates and a chunk, right? Candidates is going to be an array of numbers. And chunk is going to be an array of numbers. And this is going to return a number or null, right? And then we'll say chunk first with number. We don't want index. We don't need that. And we'll say candidates every number mod $sign equals 0, right? So this becomes, so then this we can just do this. We say divide by, actually add the divide by to our imports. Divide by, right? Divide by that. Divide by, and we need a number, so let's just do 10,000 for right now. So what's my syntax for that? Divide by that by 10,000. Good. Okay, good. That gives us back an array of numbers. All right. And then we have an array of arrays at that point, right? So we need to, so if I call map on that, is it going to do map in sequential order or is it going to do it in parallel? Hey, we have our answer. So that's awesome. It worked. It took way too long, but we have a working answer. So we'll put that in there and in there. We know we need our numbers to be something like that. That's hilarious. Yeah, we got a working answer. So let's test it to make sure that's the right answer. Yeah, we got the right answer. So now we're optimizing at this point. That's hilarious. Okay, so good. All right, so let's optimize. We've got 15 minutes left to optimize. So evens up to 10,000 divide by, and then we're gonna map. So let's do this. Then chunks. Chunk. We'll do this. chunks map evaluate candidates chunk $, right? Then results order by -1 or $, and then results, then answers 0, right? Should that work? What are we telling me here? See, expects 2 arguments but got 1. That's fine. We have candidates, right? So this should be candidates and $. Yeah. There we go. We're able to call order by with arguments array number null. Ooh, we got to filter out the non-nulls first. So results, filter, $, does not equal null, right? And then results, order by $. If you haven't noticed, I like the then syntax in Dataweave. What's this say? Results order by array number null. Unable to order by with arguments array number or null. Array number or null. Results. Oh, it's because I'm going to have an array of arrays here, right? So we want to flatten. Let's see. We're getting messy. So let's flatten this, right? Then results. Flatten results, right? And then filter results does not, so let's do this. $, does not equal null. And then answers, then results, order by $. Still doesn't like that. It's telling me it could be null. Unable to call order by with arguments array number null. Oh, it's because there we go. That still isn't going to like that. So this should be filter $. Yeah, it should be not equal to null. Yeah, that's right. And then filter results order. Let's try running it and see if it works. Okay. I think it's going to fail. I think we borked the code somewhere. That's my technical term. Yeah, it failed. Debug console error is results ordered by negative I. Yep, yep. That doesn't like that. We'll just do this. Default empty array. No, still gonna blow up. So can't call order by because it thinks that it's an array with nulls. Potentially an array with nulls, right? An array number or null. Okay, so it should actually be, it has to be an array. Why would I get null here? It's going to be something in our evaluate candidates. So if our evaluate candidates returns, oh, should be an array of numbers, right? So first with, oh no, so no, we're returning, okay, yep, that makes sense. So we're not flat, we don't even need to flatten this. Okay, so this is, we're passing an array of numbers, we're getting back a number and a null. So we have an array of numbers or nulls in our chunks. Each chunk is now a number or a null, right? Here, let's do this. Let's just do this. Let's take this out, right? And see what we get. See if it takes it a long time and go from there. We may not get any optimization at all because of the map, right? If we don't, then, oh, okay, so we got a lot of optimization. Returns, end of two, expected root to be, but was null. Right, okay. So the first answer is null. $sign. So we've still got nulls in our results at this point, right? So, and it's not an array of nulls, it's an actual null. So what did we do wrong here? So results filter. Let's try that. Is that all it was? Then, yeah, that's all it was. Then results, $sign, results, order by negative $sign. Is that gonna, it still doesn't like that. Results order by, yeah, okay. But we're gonna try that and see what we get now. Null checking is the worst, you guys. I guess I could return 0 instead of null on that function, right? Do first with, default it to 0, and then throw away everything that doesn't equal to 0, and that way I guarantee I'm getting a number back. And then that lets us also, once I've done that, that lets me order it. Where's my, yep. So this is still running pretty quickly. It's increased the number, the chunking has actually slowed down the processing of the the other ones, right? So this went from like 5 milliseconds to 212. This one went down, and this one went up. So interesting. So we'll see. We may get uh, we may get a performance difference, or we may not. I don't know if the map is going to give us a speed boost. If the map doesn't give us a speed boost because if we're ordering, it has to process the whole thing every time. We may not be able to get any advantage from Dataweave's like laziness, right? Um, so I think we may just have to go back to what we had before, which was really slow but worked. I don't know. I'm going to let it run. I don't think this is actually going to give us the right answer. Or if it does, it will be lucky if it gives us the right answer, right? Because there's no guarantee that this um, is the correct item, right? Why don't we do this? We'll take this out as a null. Take this out, and then wrap this whole thing, right? And default it to 0. Uh-huh. And then does not equal 0. That then lets us then results order by negative dollar sign, right? Does that let us do it? Negative dollar sign. Oh, we need results here. Results. Order by negative dollar sign. We've guaranteed that it's a number. I think that'll actually work. Yeah, because then we default everything that's a null to a 0. We're not null checking at that point. We've guaranteed everything in the array is a number. We throw away all of the ones that are zeros, and then we order, and then we get back our result. Is there a way to cancel this test? Uh, nope. It's just going to have to run. So, okay, but we have what should be a working solution. So, so okay. I think that's going to stop us for today. I will. Thanks for those who attended. Appreciate the conversation in the chat. We'll do another one of these tomorrow at the same time. And have a good day. Oh, I can stop it here. Let's do that. Let's stop it and run it. Is that going to work? No test. Oh, because we're in the wrong file. There we go. All right. Want to get a passing test that doesn't take 10 minutes. I probably won't. So I'm going to let that run, and I'm going to end the stream, and I'll update tomorrow on how long the test run took. But we have a right answer. We solved the problem. All right. So folks, have a good one. I'm stopping the stream.